turn it a little more to the left. There you go. Thank you.
All right,
There's one terrorist left, and that's Jeff with his math and his pen.
Oh yeah. Wait. Let me make sure everybody's with me. Why did you break it up as 49 times 2?
Yeah, because
49
is
square root.
49 is square rootable,
Yeah.
right? Our new adjective of the day.
So the 7 comes out?
So you break that up. Now don't think about it, you can say that, but I want you to understand what you're not taking anything out. The square root of 49 is 7. Nothing's really coming out, because I can't just take something out of a radical, I just do the radical, right?
You can't factor a radical.
We can't take something out of it, but you can do something to a piece of it, sure. Is that cool? If you do this in your calculator, do square root of 98, and then do 7 times square root of 2, they of course are the same number, because we just proved they are the same number.
Or you could factor that out like 2 that give you 49 and 7 and 7. You understand what I'm saying?
Totally. And then you can see why a 7 comes out. The square root looks for groups of 2. Cube roots look for groups of 3, so forth. So if I hit you with something and you get knocked down, no, if I hit you with something like this here, like what, Jeff? I don't know.
What if you're doing questions?
Yeah, we're doing a review right now. They're just kind of,
What you can do for yourself is start breaking it down. That's what Pat's really saying.
yeah.
Because the fourth root is looking for groups of 4. So let me break 32 down.
Okay.
16 times 2.
Right.
8 fourths.
4 times 4.
And then
2 times 2 times 2 times 2 times 2.
60 by 2. So it's 2.
So then it's a 2 and another.
So you can break that up as the fourth root of 16.
60 by 2.
Fourth root of 2. What's the fourth root of 16 gotta be?
2.
2, because it takes 4 2's to make 16. The fourth root, the question associated with the fourth root is, what does it take 4 of to make this? 2. So that's why the answer for this is 2. What's the fourth root of 2? I don't know. Some ugly number. What does it take 4 of to multiply by 2? I don't know. 1 point something.
It's not a real number.
It's a real number. It's just not the prettiest real number.
4 times.
So to be a real number, real quick, to be a real number, you just have to be able to be found on a number line.
Yeah.
And I can find square root of 2.
What number?
It's around here somewhere.
So
I can find it on there, so it's a real number.
If you have a negative 4 and a negative inside, that can't be, right?
You can't have a negative inside of a even root.
So
right?
that would be a 0 empty set, correct? Or
Not empty set, really. It's not. I'm not looking for a solution. You would just say not a real number.
Okay, so
Yeah.
what I'm saying is there was a problem on 7
because a
1.
negative times a negative.
So if I had like this,
you need a number of
4
negatives
and
to
a
come to
negative
nothing
4 on
but
the
be
outside of
positive.
the
That's not a real, right?
No, no.
this is not real.
Fake.
Because you have an even.
Totally fake.
It's imaginary.
All right, how we doing there? And again, why is that not real? Because 4 negative 2's multiply to be positive 16. 4 positive 2's multiply to be positive 16. There's not 4 any real numbers. So, a number repeated 4 times that multiplies to be negative 16. You can't do it.
An even number of negatives.
Any even number of real numbers will multiply to be positive. I don't care what they are, right? Because you have 4 negatives or 4 positives. That's exactly why a cube root, why an odd root works. Because if these 4 are negative, you still have a negative left over.
Which is going to make it negative.
So like we already did the cube root of negative 8.
minus
Negative 2. Why? Because it takes 3 negative 2's to make negative 8. 3 negatives, 2 cancel, you still have a negative. That's why odd roots are fine with negatives, even roots aren't. They lead to freaky ass math. It's the technical name.
Oh.
Well, how did you get that?
Freaky ass math, yes.
How did you get that 2 out in front of the 4 square root?
Here?
Yeah.
Because what is the fourth root of 16?
2.
2. Because it takes 4 2's to make 16.
Yeah.
Another way to do this problem here, let me do this another way. Because I think this is a way that a lot of you guys are going to like it for these uglier numbers. If you do we broke this all the way down to this, right? Let me see if you guys are cool with this. Fourth roots look for groups of How many things? So here's a group of 4 2s, right?
Yeah.
How many extra 2s do you have?
One.
So you're going to have a leftover 2, and for these, the 4 through takes out one of them.
Okay.
It looks for groups of 4 and takes one of them. Whereas what's a 4th power 2? If I feed a 2 to a 4th power, well, I had one of them, and now it makes it 4 of them. A 4th root has to do the opposite. I had 4 of them, well, now it makes one of them. Right? It's got to cut it back down instead of build it back up. So that's another way to do this problem, right? Is break it all the way down and find, do I have anything that has a group of 4 in it? And I can pull out one for every one I see. Just to remind you guys, you could actually do this also. What did I just figure out? 32 is 2, 2, 2, 2, 2, so 2 to the
4th power.
fifth.
Power, I'm sorry.
4 goes into 5.
One time.
Ones with 1 left over. Hey.
Long division.
Oh. Sorry. Right, I mean, so every single way to look at it, of course, has to come up with the same answer, or else I'm going to throw them out. They're not valid. Every way to look at it comes out with the same answer. Thank God.
So the easiest way to look at it would be an even number of negatives equals a positive, and odd number equals a negative. Odd number of negatives
That
still
we
equals a
know,
negative.
but that feeds into why even roots can't handle negatives, but odds can.
Mhm.
Let me see. Now I forgot where I was going to go after. Oh yeah,
Top right there.
Huh? No, I was going to go somewhere else after this one, but we're getting a little extra thing about Roman numerals here too. What about this guy?
Same thing, but they declare the negative signs.
So the 4 through to 16 is 2, because it takes 4 2s to multiply 16, you just put a negative in front. Which is related to this. Ix is 9. Related to this, what's negative 16 to the 1/4? Can you do that?
Also minus.
What's being raised to a 1/4 power? And I'm kind of segueing into, what does a 1/4 power mean? What's a fractional power mean?
Yeah.
Yeah, 4th root of what?
Negative 6.
16 with a negative outside.
Yeah.
So
What am I taking the 4th root of? 16. The negative is not being raised to a 1/4 power, is it? So that's the same problem then. If I wanted to say the 4th root of negative 16, now I'm saying it.
Yeah.
So there's a problem like this in the homework that some people said you couldn't do. Yeah, you can do it. The negative's on the outside. Here, the negative is on the inside. So this would be 4th root of negative 16, not real, is the perfect answer there. Say no solution, I know what you mean, but technically, I'm not solving anything. I'm just trying to simplify.
would empty set qualify as well or no?
Same thing as no solution. So be careful, that's not really technically right.
Will you deduct points for that?
How are you guys doing? So to tell you honestly, you see how all those different things connect together? I can't really,
Hey Jim, just to be sure for test reasons, would you deduct points if we give the wrong, like instead of not real, empty set or
well,
no solution?
probably not. I mean, come on.
Okay.
But I'll put a little note on there saying if that was mean or you'd lose something here.
Bad boy.
So just to show you, I couldn't really do a problem like this unless I understood something, Jeff. What? Okay, that'll work. Unless I understood, I mean, adding radicals is pretty simple if they're already like terms. But if I don't understand how to simplify a radical, I can't add something where they're not like terms. I'm still going to get somebody tell me that this is 5 squared root of 68, which is really neat.
No.
You know it's
You know?
you know
just
it's
like
not real when he goes
X
out
plus
as
y is xy, or x plus x is x squared, or something freaky. You gotta be careful about that. You gotta stop yourself from that. These are not like terms, but what can I do with each one?
9 by 2,
Good.
and the other 25 by 2.
And then square root of 9 is 3. 3 radical 2's plus 4 times 5 radical 2's. So I got 3 radical 2's plus
23.
20 radical 2's, 23 radical 2's. Okay. And I really don't think you can fully understand this unless you understand the other way. You can multiply like radicals. So that's why I did 7, 5 first and kind of worked my way backwards and sideways, because they all intermingle.
I don't understand how you did the 4 times 5. How did you
I gotta make sure that I didn't really make that. That's a 4 in front, right? Not a 4th root.
I was like,
Yeah.
wait a second.
That's a 4 coefficient,
Okay.
not a 4th root.
Okay.
Yeah.
Cool.
So how would that even work?
You can't. You're not allowed to pop a 4
I was
out.
like, that was neat. How'd you do that?
That would be neat.
That is really freaking neat.
Okay.
That's great.
So the board, I gotta be careful. All right. Let me give you guys a couple to try then. before we get too far. No, we're not there yet. I'm still on my review kit. Yeah. Now, everybody see that's a cube root, right? We really put that in there.
Yeah.
Not a 3 out front, it's a cube root. Oh, yeah. Ooh.
Is that root or coefficient, the 3
It's a coefficient, yeah.
coefficient?
Where did those numbers come from that you have? Oh, there it is. Okay, I was looking here.
Not the second one. Try the first one.
You set something that's not the area equal to the area. What's the area of the triangle?
Lost in a second.
It's not based on size.
Yeah, lost.
This would be based on side. Triangle is half that. So it's half based on side. Just lift off that. So maybe try these things. Be really careful on these, even though you might be able to find your cube root button in your calculator. I do not want to see some big ugly decimal answer here. That's not right. It's like me saying reduce this, and you say, oh, that's 0.75. No, that's not reduced. Put it in your calculator. Don't give me that crap. Your calculator will pass the class. Go to the next slide. All right, let me catch up to you guys. This is a cube root. So you're looking for numbers.
27
Yeah, 27 is good because I can take the cube root of 27. So the first step is you break that up into the part you can do and the part you can't. You do the part you can do and you don't do the part you can't. It's amazing. So cube root of 27 is 3 and you still have cube root of 2 because we don't know what that is.
Well, I came up with that answer, but I did it using a 9 and a 6.
Neat. Now how did you do that though? Because you can't take the cube root of either 9 or 6.
Oh, yeah.
Right? So you gotta at some point get that 27 because it's the only piece of 54 that's cube rootable.
Right.
You see what I'm saying?
Mm-hmm.
Yeah. So you gotta be careful. I mean, there's a lot of different ways to factor 54, but you want to factor it in a way that there's a piece you can do something with.
Yeah.
In this way, I can't.
I guess I was doing square root then.
Yeah, exactly. And that's what I see all the time. I see people on the next step, they lose their 3's,
Yeah.
which changes the whole problem now.
Yeah.
Because now 27 won't work in a square root, or
Forgetting some.
so you got don't lose those little root numbers. They're called indices. The index of it. Again, I don't care about names really too much, as long as you can do the work. What about the second one here?
Yeah.
What can you do with this first piece?
4 by 2, 10x.
Good, so split up the 8 into 4 times 2.
Yeah.
What can you do with this guy?
16 by 2.
Good. 16 times 2, and then the square root of x squared I can do.
Yeah.
I think on this one you're assuming that the variables are made from positive numbers. You remember the square root of x squared should technically be absolute value of x, because you can't have a negative come out, but we're not really going to worry too much about that. What do I get? So square root of 4 is
2
times 5.
10x.
Is that cool?
Yeah.
Square root of 4 is 2 times 5 is 10. Plus square root of 16, 4 times 3 is 12. Square root of x squared.
X outside.
And what's left inside?
2.
Is 2.
So 22.
And now are they like terms?
22x.
Good. They have the same variable and the same radical piece.
Yeah.
22x.
I love it. So 10 of these plus 12 of these is 22 of these. I love it. So the old idea of like terms is not an old idea. It is the idea. Same variables, same amount of each. In this case now I'm looking at radicals as if they're variables really, because I don't know what the hell they are. So we can treat them like a variable. Yeah.
What happens to the square, x squared?
What is the square root of x squared?
X.
X. Cool. Right.
Can you give it again? It's so
Sure.
dramatic, I mean, so I lost you.
So I look at this by itself.
Okay.
I say, now what can I do with the square root of 8? What piece of it can I do the square root of?
4 and 2.
Good, 4 and 2.
Okay.
Now what can I do with the 32?
16 and 2.
16 and 2. Right, a little bit
And then
further
you're
out
gonna
there.
have the x squared by itself, right?
Yeah, because I can do that.
Okay.
Right? So see, I'm always breaking it up into a piece I can do and a piece I can't. So I can do this piece, I can do this piece, I can't do this piece. Can't do this piece. So now I get my 5x times 2 radical 2 plus 3, 4 radical 2, x. Well, and if people would, sometimes I don't think you guys realize all I'm doing is that is 4. That is x. Everything else is the same, just replacing what I know to do with what it is. That's all I ever do in math really is. That is this, which I can use easier than I can use that, so let me make it this. So here I get my 10x, radical 2, plus 12x, radical 2. So I got 10x of these, 12x of these, so I got 22x of these. Cool. Okay.
Can we ask you questions from the book or yes?
Sure. If there's something I've covered.
Yes, page
It is 578,
74.
578, number 49, please. 578.
Number 40 now?
Yeah.
Oh, well, I haven't covered that.
Kind of
I think I said there was still some stuff I had to cover.
rationalize.
Yeah. I don't think I've done rationalization yet, have I? Rationalize.
In the exam, you tell us to make it as rationalized, or you did mention.
Okay, here we go. We do this. This will close out section 7.3. Rationalization is like a psychology term. I don't know if you guys know how you rationalize something away. As a human being, we rationalize things. We try to make them make sense, but they really don't. Rationalization in this case means, what kind of number is this?
So it's the square root of 7.
What kind of number is it? Is it a whole number? No.
Yeah.
7's a whole number. What's square root of 7?
Irrational.
It's irrational. So rationalization means somehow getting rid of irrational pieces, right? Does that make sense? If I want to rationalize something, I want to make it not irrational.
You simplify the number without the
Fraction.
So for example,
Radical 7 over 1.
if I have 1 over square root of 7, I want to, in fact, this is what we normally do. We want to rationalize
Multiply by the square root of 7.
the denominator.
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 Denominator. Don't
I
make me
don't have
make
to
a
say it
scene.
that way because now we have Jerry Brown as governor, but I still want to say it.
Make me make a scene Terminator.
Why can I not do square root of 7?
7.
I know, but I'll catch up with you. Why can I not do square root of 7? So you got it, just sit there and wait.
It's a prime number.
More than that, it's prime, which means it's got a big problem, but there's only, how many 7s are there? One. How many more 7s do I need so I can do the square root of it? So this is a lot like chapter 6 in one way, in the best way. You just give it what it's missing. I call this completing the root. Why do I need one more 7? Because the square root needs groups of 2. So I give it, I can't do this now, because can that 7 go with that 7?
No.
Because they're not the same. Alright, so I better multiply by square root of 7, top and bottom. Whatever I do the bottom, I better do the top. So what do I get on the top now?
7.
1 times this is square root of 7.
49.
No, 49.
Square root of 49, which is 7. So remember, this is like how much, what's another way to write square root of 7 as a power? 7 to the
1 over
1/2, right? Fractional power is a root.
Yeah.
How much of 7 are we trying to take half of it? So when I put half of a 7 together with half of a 7, what should I get? A whole freaking 7. Right? You guys see what I'm saying?
Yeah.
So you could do this step if you wanted to, but you really shouldn't have to. You've made it. What have we done to the bottom now? The bottom used to be irrational. What's the bottom now?
Rational.
Rational. Rationalize the bottom. Make the freaking bottom rational, not irrational. One reason why we do this is because it's bad enough that I got an irrational number. It's even worse that it's on the freaking bottom. So one reason we do this is because now I could combine this with other radicals easier. Right? But it has further uses for further math about being able to rationalize. Sometimes you want to rationalize the top, believe it or not. But most of the time it's the bottom that we rationalize. I call this completing the root. And here's why. It sounds like some cheesy 1980s cartoon movie, but complete the root.
To complete the square root you need.
Complete the root. Because what if I had a cube root of y?
Yeah.
The same. You want the
Same idea.
Yeah.
How many y's does he need?
3.
3 total, so how many more does he need?
2.
Good. So do you see what I mean by complete the root? Just look at the root. Root says, oh crap, I need 3 of everything. Right now I've only got 1. I desperately want you guys to get this because it's stupid easy. It really is. That root needs 3 things. It's only got 1 y, so how many y's are you going to give it? 2 more. Whatever you do to the bottom,
So square root of y?
cube root
Oh, okay.
of what it's missing. Whatever you do to the bottom, you have to do to the top. So on the top, I get 2 times this. Just slam those together, right? On the bottom, I'm going to get cube root of y cubed. So what's the cube root of y cubed?
Y.
Because the cube root and the third power kill each other, don't they? 3 goes into 3 once with no left over. Right? On the top, I get this mess here. So I make the top ugly, but the offset is I make the denominator very nice, which overall is a better way to be. So again, from the beginning, I knew I needed 3 of everything in here. I only had 1 y, so I gave it 2 more y's. Whatever I do on the bottom, I better do the top. So the bottom is now going to become a whole y. Aw. Because here was only 1/3 of a y, right? What's the cube root? Y to the 1/3 power.
Yeah.
Fractional powers mean roots. Why? Roots cut things down, don't they? Fractions cut things down. They go together. And this is 2/3. So of course when I put them together, I'm going to get a whole y. What's 1/3 plus 2/3?
3/3. 1.
Which is 1.
1.
3/3. So you can see that there too. I desperately want you guys to get that. Because here's probably well, this is even uglier than the book does, I think. Let's see. Yeah.
What the?
So,
Fractional
Again,
square root?
what gets you through math? Break the problem down.
Alcohol.
Like, in addition to alcohol.
Spoken like a true college student.
Like, it was like right there too. You're waiting.
That was nice.
I was waiting.
He's even
I
went all
knew you
semester
liked
to
it.
use that.
That is funny. What gets you through grading that? The problem is, do I need 4 27s? What's a better way to look at it? What's 27 already?
3.
3 threes.
Yeah.
Right.
So you
So how many more threes am I going to need?
2 more.
Because it's a fifth root, right?
Right.
So you have to piece it together for yourself. So I need a fifth root. I need 2 more threes.
You need 4,
How many more A's?
3.
Because I've already got 2. I need 3 more to make 5.
So A
See
cubed.
why I call it completing the root.
So you have A cubed, right?
8.
And
And
then
how many
just
more B's do I need?
one more, just B.
One.
Whatever you do to the bottom,
Gotta do the top.
got to do to the top.
So you need W to the 4th.
No, whatever I do to the
Oh,
bottom,
don't think it.
I've got to do the top. I don't really care about the top. It's just going to end up as a big trash pile. I'm trying to make the bottom pretty, right? For whatever reason.
They can really do that.
Now, what the hell do we get here at the end? On the top, can I actually put the W in there with them?
No.
They both have a,
5. You can't do that.
so I can, right?
Yeah, you can.
Yes.
9A cubed B W.
Okay.
Because they both have a fifth root. Why couldn't I put the tops together here? Because this did not have a
Oh.
cube root. Now they both have a fifth root, just slam them together.
Okay, divide now.
So the top is just going to be fifth root of W times fifth root of 9A cubed B, so I get 9A cubed B W. And so I just put them together.
Where? Oh, okay.
What do you get on the bottom now?
3A.
Exactly, 3AB. I get 3 cubed, 3 squared, so 3 to the 5th. A squared, A cubed, so A to the
5.
B4, B1, so B to the 5th. I designed that. What happens with all these?
Added them?
Shabba! Right, of course, yeah. When I'm multiplying, right? So I add exponents.
Alright. So it turns into just 3AB
Exactly.
with no radical.
Technically, you shouldn't have to even do this step. You forced it to be a whole 3 and a whole A and a whole B. Because right here, isn't it 2/5 of an A?
Yeah.
And if you multiply by 3/5 of an A, it shouldn't be surprising you get a whole freaking A. I just watched Austin Powers again this weekend, so I guess that freaking.
Nope. The,
Stop pumping the freaking laser. Yeah. If you've never seen it, I'm sorry.
if you have,
I'm sorry.
well, I'm sorry, yeah.
No, it's okay.
Oh, wait a minute.
Okay.
All right, so I call, when you see rationalization, I personally like to think of it as completing the root because that name tells you what the hell you're doing. You're giving this what it's missing so that the root can be done. Why am I allowed to change it? I couldn't do that before. Right? If I had square root of 2, I just can't multiply by square root of 2 out of nowhere. It's because there are 2 sides. There's a top side and a bottom side. So whatever I do to the bottom is balanced by what I do to the top. Just like an equation. Whatever I do to one side is balanced by the other side. Right? So don't suddenly think you can destroy all radicals. You can't. Here I can because there's not an equation, but there's a ratio. Top and a bottom. Maybe. Now sometimes I get people do this. And maybe you can tell me where this comes from. If I had like 3 over radical 2, they tell me that's 9 halves. What do you think that person did? They squared it. Why do you think they would square it? It's not a horrible idea, but it's one you should certainly throw away as soon as you think about it.
'Cause it doesn't.
They squared the top and the bottom. Are you allowed to square the top and the bottom of a fraction? No, you can only multiply or divide. Because those are the only things you can do that will maintain the ratio, right? So we know 1/2 is the same thing as 2/4. But if you square top and bottom, don't you get this? Whoa, that's freaky. Right? I'll give you half of the money you work, which is the same thing as 1/4 of the money, which is the same thing as 1/16 of the money. So, go on. No, don't like that math. Please make math the way it's supposed to be.
How do you get the 3 AB? I don't understand that.
Are you cool here?
9.
Let me see.
'Cause there were-
That was, yeah,
3 and 2 make 5.
right,
And what's the fifth root of something to the fifth power? They cancel.
okay.
Cancel, cancel. So I'm left with 3AB.
Oh,
Fifth root of 5 threes is 3. The fifth root of 5 A's is A.
oh.
Fifth root of 5 B's is B.
So that 5 root on the outside cancels all those 5s.
Exactly.
Okay.
Because what's another way to write, just looking at this by itself?
Uh-huh,
Wouldn't this be A to the 5 over 5?
uh-huh,
And then just a whole A?
yeah.
So instead of doing this middle step, let me just kill these.
Oh, oh, okay.
That's a good point. What would the, these are going to freak you guys out. What's the 80th root of A to the 80th? A. And it's really, it's exactly like this. What's 80A divided by 80? A. Why does this work? Because multiplication is the opposite of division. Why does this work? Because rooting is the opposite of raising to a power. These 80s cancel. These 80s cancel.
Right.
Right?
Uh-huh.
You make it through that. But this happens all the time in math. There's a lot of analogies in math because it's actually the same stupid idea all the time. You get a function, you get its opposite, they will always kill each other. I don't care what the hell they look like. So here I've got a function, I've got its opposite, they kill each other. Of course. Right? And of course now we understand if I had this, if it was only 80, it would kill each other totally.
Right.
So there's still at least 80 in there, so a whole A comes out, but what's left? 80 goes to 81 once with that extra A left inside, right?
Okay.
So the idea still applies, just not perfectly because that extra crap on the inside, right? Okay.
Page
594? Perfect, I love it. No, page 594, section 7.5, I think, right?
Yes, 7.5.
What section are we getting to today?
We'll see.
We'll see. Yeah, exactly. How about a day off?
60, yeah.
Just don't show up on Wednesday. What's your day?
Shut up. You win.
Square, white.
Don't make me make scene swingers references because I will.
What's your gut tell you to do here? What's just screaming at you wants to be done here?
Divide 64.
Yeah, so 60 divided by 4 is 4.
And then
The y's
Cancel.
cancel. How many x's are left alive?
1.
Where?
in the bottom.
Alright. Now what's the square root of 4? 2. Can't I do that now? Can I break them up?
Yeah.
What am I taking the square root of? 4 and x. Square root of 4 is 2. Now what can I do with this? Something.
You multiply.
I don't like a radical on the bottom.
You multiply.
Multiply by what? What's he missing?
X.
He's missing another x, right? So there's a little cleanup at the beginning to make it into a problem like that one. Not quite like that, a little bit better, right? We just clean up exactly what you want to do, you can do. Why? Because they're all in the same root. You're allowed to divide then, right? So kill, 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 kill. And then you're left with one little x left alive, so you go in there and little rescue mission.
2 radical x over 2 over x.
We're helping people now, right?
Over x.
Half of an x, I gave him his other half,
X.
so it makes a whole x.
Wow.
Or another way, square root of x from square root of x to square root of x squared, which is x. So it started off a little ugly, but not too bad at all because you just reduce. Then you break it up so you can see that the bottom isn't a radical. I don't like radicals on the bottom. It's sort of like not ending up with a negative power. Like if I had this, why is that not quite done? Because that can go down. So if I get this, why is that not quite done? Because there's a radical on the bottom.
Right.
You rationalize it. It becomes like an automatic thing.
Really?
The numerator, you can take 4
Killing me,
out of the bracket. You can do it.
Sure. Square root of 16 is 4.
4.
Square root of 4 is...
No, you complete. 4 between brackets, 4 xy. No, between brackets.
No, it's still in there. right? The xy is still in there, right? Is that what you're saying?
No. The root is all the same.
No, be careful. That's your value.
Numerator, 4, open the bracket.
You mean like that?
No, bracket.
Bracket.
Yes. 4, xy.
Where'd the square root go for the xy?
You keep it.
Where'd it go? Where is it?
No, keep it.
Where? Here?
You will have to keep it.
Here, right?
No, it's inside. I'm told.
Here.
Yeah.
Yes. I mean, the xy is still in the square root.
I have the solution. Maybe it will be easier. Just tell me what is wrong. The second one.
Oh, you just didn't go far enough. You just didn't. Now you're here, right?
Yes.
You're here. Now just go one step further. It's sort of like that's the answer. Just like getting this. If you got that as an answer to something, it's right. It's just not in the right form. You haven't reduced it yet. This is right. It's just not in the right form. You haven't reduced it, or in this case, simplified it yet. Right? What you did is exactly what we did. You just did it a little more. You just actually broke it up.
Yeah, that's what I mean. Yes. Yeah.
So you can see the 4's go away. Yeah. Where over here, you just do 60 divided by 4 is 4. I mean, both of them are the same way. You did the same thing we did. You just showed it a little bit more. Yeah. Okay. Oh. I can't remember now if I did that.
This number 60, I got the same concept without making a rationalization.
Yeah.
Number 60,
Killing me.
without the same
Killing me,
concept,
Smalls.
without rationalization.
There's something. There's
Oh, yeah, because it's simplified the x squared.
That's
Okay.
The denominator, you can take
be like this.
x. You are correct on the numerator, correct. But the denominator, you can take x out of a bracket.
Okay, sure.
No,
No. So again,
numerator.
so what you're saying is something like Yasmin did. And so in this particular problem, there's two different ways to do this problem. And the other way to do it is to kind of attack the top and the bottom separately.
Yeah.
In a way, I guess, but you really did more than that. But let me just catch up to you. So you got like this, and on the bottom you got this. Square root of x squared is x. The square root of y is cancel, so you get to the same place we did. Beautiful. Will it always work that way? No. So I always try to show you the most general way. And since we're running out of time here at the end, that's the way I'm going to show you, period. If you got other ways, sure, show me. Great. I love it. You should be making math your own. You should be coming up with different ways that work and then saying, my way works, why didn't you do it this way? I was like, oh, your way's great, I love it. I just don't have the time to show all the different ways. Okay.
I try and do it my way, but it doesn't come out right.
No. And real quick, this last little piece of this section. If I multiply by square root of 2, that would help him out, but not him.
Right.
If I multiply by square root of 3, that'll help him out, but not him. You guys see what I'm saying?
Yeah.
What do you got to multiply?
So I'm going to multiply by both of them at the same
That's
time.
what I had a feeling you're going to say that.
Right?
But I've got to change the sign. I don't know how you guys, you do what's called the conjugate. If I multiply by square root of 2 plus square root of 3. The reason I do this, I'm going to have to FOIL this out, right? If the middle term was alive still, it would be a radical. But I want to kill all the radicals on the bottom, right? So what's going to make the middle term cancel is if these look like difference of squares. What do you get now? What's square root of 2 times square root of 2?
4.
Square root of 4, which is 2. Minus radical 6 plus radical 6.
So that cancels.
Minus, what's root 3 times root 3?
9. 3.
Square root of 9, which is 3. So this is called the conjugate, which is a big fancy word for change the sign in the middle. Right? That's all it is. So on the top, you just got to, what do you get on the top?
7,
Multiply 14 and then 21.
Square root of 14 plus
21.
square root of 21. The top is just one thing, so you just distribute it, right? But the FOIL is only one piece here. So what if the bottom would have been, what, Jeff? I don't know, square root of 5 minus 2.
So hang on,
Oh.
you finish that then? You do the turn the negative.
Oh, yeah, sorry. I got so focused on over -1, right? Because 2 minus 3 is -1. And then you can actually, if I divide by negative, don't they both change signs? Okay, cool. So you try to make the bottom a number, and then you could simplify it if you can. So now I rationalize the bottom. Are there any radicals left on the bottom? No. So I rationalized it. I got rid of all the irrational pieces.
Yeah, because the bottom can't be negative, right?
It can be negative,
Okay.
but in this case, it's easier to just get rid of the bottom entirely. What would I multiply by here? What's the conjugate?
5 plus 2.
Yeah, don't make it more than it
Five
is.
plus
Just
Plus 2.
multiply by different sign in the middle.
Yes.
Right, so on the bottom I'm going to get, what's root 5 times root 5? Square root of 25, which is 5. Minus 2 root 5s plus 2 root 5s.
Nothing.
And I designed it to do that. What's -2 times 2? Well, that kicks ass. And then what do I get here?
30
Square root of 30.
plus.
6 on the two on
Two.
the radical of 6.
Not square root of 12, right?
No.
That 2 is not in a radical. I can't put it in there. So I get 2 radical 6s. And of course the bottom is just 1. So you get radical 30 plus 2 radical 6. So when do you know to do the conjugate? When you have 2 terms on the bottom, right? When you have a radical, at least one radical, there's 2 terms. If there's only 1 term on the bottom, I can attack it directly. Where's a good example? There, right?
Yeah.
When there's more than 1 term, I've got to attack it with the conjugate. Okay. Alright, so that's Sim 5. Now, it shouldn't be amazing that the next thing we do with these radicals, we've multiplied them, added them, subtracted them, divided them, right? Simplified them, rewrote them in different forms, we've done all this crap with them, but one thing we haven't done with them yet is the main thing in algebra, which is deal with them when they are in equations. I like your face.
Equations.
Staring death in the face, like, oh God.
So as always, you start off super easy and progress from there. Here's the easiest example of an equation with a radical in it. Now you can just look at that and tell me the answer, maybe. Or you take the square root of it, you get 7. Okay. But how do you attack it with algebra? Because they're not all going to be that easy. How do you kill a square root? What's the opposite of a square root? A square. We just said earlier, square roots and squares, cube roots and cubes, they kill each other. They're opposites, right? So square both sides. So squaring a square root kills it. So on that side I get x.
49.
So here's another way. Over here I kill the radical by multiplying top and bottom. Over here I kill the radical by using them to both sides of an equation. So as long as you have 2 sides somehow, I'm allowed to do stuff to each side.
You put the number 2 from yourself?
Yes, that's from me.
Where? From you?
Yes, in fact the whole thing's from me, but this 2 is
No
the
wonder
first
it's
step.
so. No wonder so evil.
So what if I had this then? No, I just throw it from the board, then there's stuff up there. I'm like, wait a minute. Same thing here, same exact thing here.
Square both sides.
Notice how when I square this side, there's no foiling, is there? Can you imagine to foil something with radicals in it? Do you want to do that? So when I don't have to, I'm not going to. That's going to become a big point in a minute. This radical is by itself. If I am the president of a country, I have radical elements. What am I going to do with them? I'm going to isolate them, get them by themselves, and kill them. So now here, my radical's by itself.
Yeah.
So I'm going to go in there and kill it.
Yeah.
Right, where
What do you do on one side? You got to do the other side.
x equals 9.
Now you're
2x
gonna
plus
put
1
2x plus 1
is
Equals
9.
9.
equals 9, and now you're back in chapter 2.
Oh, okay.
Right?
Oh, you get rid of
So
4.
2x is equal to 8, x is equal to 4.
Now I didn't check this first one because it was pretty obvious what the answer should be. But you really have to check your answers with radicals. Because when you square both sides of something, you're forcing them to be positive no matter what they used to be. So you might get answers that don't work in the original. They work here, but they don't work there. This is going to work. Let's check it. So square root of twice 4 plus 1. What's that? Square root of 8 plus 1, 9. 3. Bless you.
Thanks.
You've got to check your work on these. You have to, because otherwise you're going to miss when you get answers that don't work. It's a lot like in the last section, I still see some people getting bad things. If I got x equal to -2, what's wrong with that?
Minus 2 over.
Zero.
You can have a negative.
Yeah.
No, what's wrong with that? If this is my equation, what's wrong with getting that answer? It makes this guy freak out.
Would be 0.
No solution then.
Oh, okay.
I got to do a similar thing there. Gotta make sure it doesn't freak it out.
You're right, if x can't be,
Right here you can write x can't be 1 or -2. What's the answer?
no
No
solution.
solution.
I can write only no solution.
Exactly. Because I want to know what the solution is. And you say, well, there is no solution. So what's up with this guy here?
You move the 3 to the other side.
So what did I say earlier? The president of a country is radical elements. You want to isolate the radicals so you don't kill anybody that's not me. Right? So these poor little 3s, they're innocent bystanders. Get them the hell out of the way. I'm going to keep going. Some of you guys might notice something, but what do I do to, is everybody cool with that? Get the radical by itself, because, can you imagine, if I squared right here, if I squared here, don't put that on your paper, but if I did, what would I have to do with this?
Square everything.
To write it twice, FOIL it, my radical would still be in the middle term. Screw that. Let me get that out of it so it's in one term here, so that when I do square, what happens?
You get rid of radical.
Cancel it directly, right?
So that'd be 3x minus 2
3 minus 2x.
equals 4.
4. Then you take the -3
X
out of
equals
the
-1/2.
So you leave with 1, -2x.
Minus half.
Minus a half. Does it check?
Yeah, check.
It does? That means you gotta be careful what you say to me. Did you check it? So if I check it, square root of 3 minus twice -1/2 plus 3 is supposed to equal 1, right?
Yeah.
Go back to the original. Don't go back here, don't go back here, don't go back here, go back here.
Yeah.
So yeah, inside you get 3 plus 1 is 4. Square root of 4 is
2.
2 plus 3 is
5.
not 1. Therefore, is that the answer?
No.
No.
No. No solution.
No solution.
Now real quick, on this level right there, you could have stopped and said, screw this problem, it's not going to have an answer because I'm trying to say square root of something is negative. But notice, when I squared both sides, then -2 became +4. When I square both sides of an equation, I lose information about the sign. That's why math said, cool man, there's your answer. To this, but not to this. Right? When you squared, you made it fundamentally different. That's why you got to go back and make sure they actually work way back here. Man.
So
If you see this, hell yeah, stop. Just like before, we saw this. Are you going to make your 2 cases? Remember that?
No.
Finals coming. Absolute value, make your 2 cases. No, don't make your 2 cases. Absolute value can't be negative. No solution. Stop. Same exact idea. Square root can't be negative. No solution. Stop.
But we have to solve it until the end, and after that.
If you want to,
check.
sure.
Yeah, and make check.
If you do go all the way to the end, you got to check them at the end.
I check it.
Because sometimes you'll get 2 answers maybe, and only one of them works or something. So let me let you guys try one of these.
Stevie Wonder?
Yeah, that's funny. I was just thinking the same thing. Maybe he just had neck pain. I mean,
So the plus 9 is in the radical?
Yes. 15 minutes, you're good.
Okay, good.
yeah, see that? That's a really good point. Somebody suggested this symbol should really be like this. It should have a back wall. Make sure everybody understands what's in it. Bless you. One of these problems, you are the president of this weird-ass country.
Who elected you? Who elected you? Jeez.
Me, I'm not the president. You guys are.
I'd vote for it, Jeff.
You vote for Donald as well?
Who?
Trump.
Shit, no.
I'm kidding. I took this morning. But you don't do that. Gas prices go down, I'll tell you that much.
Not quite right. So you might be getting close.
Coming out, it's not coming out right.
What's the first step?
Seven over.
Get rid of the 7, yeah.
So you can isolate your radical elements, right?
Yeah. Square both sides.
So now you're back to chapter 2 because you have an equation.
Oh, that's where the problem.
Square both sides. Because you can't start doing this. You can't take a 9. You can't sneak it out of a radical.
You're squaring to cancel the square root, so you get an easier problem. So it's just 5x plus 9 equals 16.
What's up?
You square root, so you get rid of the square root.
What kills a radical?
Square.
Square root, a square. Do the same thing to both sides. Now subtract 9.
Equals 1?
7 over 5.
And x is 7/5.
So
Does it check?
No.
Alright, so I got a no and I got a yes. So let's see, 5 times 7/5 plus 9, that's supposed to equal 11. What's 5 times 7/5?
This 11, not 1.
11, sorry.
Yeah. So
7 plus 9 is 16. Square root of 16 is 4, and that checks. Alright.
Say that again, Anthony.
Now, as you know, probably more levels to this. Here's the next level.
I don't want to grow up.
Good, it can be Toys R Us. Alright, let's see now.
Check 7 plus 5.
So what the hell could happen now?
7/5.
I don't know.
Pull another Stevie Wonder here. Come on.
Stop.
7 plus.
I gotta make this work, so it's always interesting.
Can you use a number that can be multiplied by 2? Like, you can use 10 because you can multiply.
I gotta be a little careful. I want to make it come out to something decent. You can very easily get really ugly numbers here, but let's see if I manage that here. Now the first step does not care what's on the other side. We care. We look at the other side and go, shit, there's more variables. But the first step doesn't care. What's the first step?
Subtract 2.
Yeah.
minus 2.
Get everything on both sides. Get everything on one side.
Alright, once you do that, you can come in and square it, right? Kill the radical element.
Just to foil that.
You gotta foil that bad boy, right? I'll do this side. What I always get right here is people tell me it's x squared plus 64. They suddenly forgot how that works.
It's x squared. X minus 8, x minus 8.
Remember that? Careful.
Is it something?
You gotta write it twice. You gotta foil it. You can't get around that.
Because if it's a squared, you're going to write the equation twice, not the number.
You gotta write this twice.
Yeah, exactly.
Boil it in our heads.
Certainly, yeah, please.
You have that kind of mental capacity.
You're not gonna like take points out.
No, I'd rather you do that anyway.
Make our head
So
explode.
you should be able to do that. Now, we are not back in chapter 2, we are back in chapter 5.
You're going to combine.
Why can I not just solve for x?
You gotta go to zeros,
Yes, why?
because you wanna get it all on one
X squared
side.
because
You're
of
gonna-
Because of this square, because of the higher power.
You're going to add x squared minus 16x.
Or
Or you're going to subtract 2x minus 1. And now you can combine like
So
terms,
now I make
correct?
this side here. No, I'm very careful about which side I go to. I want to keep my x squared piece positive.
Yeah.
Because you should have realized by now, if there's a negative in front of x squared, it makes it really harder to factor.
Why'd
I
you
want that piece to be positive.
why'd you put +1? You're subtracting it. Wouldn't the minus stay in line? Oh, it's
Minus
opposite.
negative
It's
1. I want them to cancel.
Cancel, okay.
So now they cancel.
Now you combine like terms, correct?
Minus 18x,
Yep. And now you got to factor that.
so it's x and x.
So you combined like terms, and now you're going to find out what adds to -18 and multiplies to 65.
And this isn't too evil, really. There's not too many ways to factor 65.
No, I
In
feel
fact, there's really only one true way. There's 65 and 1.
that's the truth.
And then there's 5. Obviously, 5 goes in. 5 and
5,
13.
13.
And 5 and 13 make
18.
you guess, as long as they are both
Negative.
negative.
Bingo!
So x minus 5, x minus 13, right?
So x can equal 0, -5, or 13.
Are you guys cool with that?
And x plus 2.
Good. So x could be
0, 5, or 13.
careful.
-5.
Positive
Positive 5.
and a positive 13.
And no 0, right?
X can't be
Where
0.
would 0 come from?
That's right, it's not in the equation.
There's no x here.
So check.
X can't be 5. I mean,
Go
x.
back and check which one.
Gotta be careful. Now look at the domain. What makes it 0? If x is 5? Or if x is 13?
0.
Yeah, it's always an or here.
There's no
X
0.
can't be both at the same time.
There's no 0 in there, I see.
There's no, if there's an x here, then it would have been a 0 also. Now, remember, that's the answers so far. There's the possible answers. What do I gotta do with both of them?
You check.
Check.
Plug
Now, when
it
I
in.
made this in my head, I made x 13, so I expected to get 13. That's how I built this.
It can't be
So when you
5.
throw 13 in, it'll work.
It can't be
Plug and
5
check.
because if you plug
Good.
5 in, then it'll be negative.
Awesome. 5 minus 6 is -1, but thankfully here you subtract 2, which makes it still negative. You gotta be careful when you plug it in. If you notice it's negative, you gotta be careful about what it was you did next. Because you don't have a square root equal a negative yet, but you do when you hold it over. But if you just throw it all in,
So we say possible solution is this, but the checking is 13.
so now I'm checking the 5.
Then check.
So we get 2 plus square root of 9.
Yes, I'm not going to do.
2 plus 3 is not -1. Do you notice if the 3 were a negative, it would work? And that's what math is saying. It says when you square stuff, you lose information about what was negative, what was positive. So math says, that ain't fair for me. I'm going to give you all kinds of answers. You got to go back and figure out for yourself if it still makes sense. So here, what would I do? I'd have to cross out 5, circle 13.
Okay. So we say after checking the 13 is okay.
13 is the answer. Cool.
That would 5 not work? Because that would,
Because that doesn't check.
and it would have to equal a positive number for it to check.
It'd have to equal -1 for it to check.
And 2 plus 3 is 5.
5 does not equal -1.
You know, that doesn't make sense at all.
So it's not enough to keep to leave it like this.
No, you got to tell me what the
You
answer
have
is.
to one and
To
two.
check.
It might, both of them might work. Careful, they might both work, but you got to check and see which one does. Sure, both of them could work. Yeah.
Yeah, because it has extra.
I remember saying you could go. Dots you could.
That's what they drink.
Oh, no. None of that.
It is a
Then quiz.
One is 2.
On Wednesday.
One is 2, no. Just start.
6.
It's the last 3 sections out of 5.
Okay.
And then chapter 6. And really, I'm obviously going to make problems from chapter 6 that have factoring methods from the end of chapter 5. So that's how I'm going to not make a ton of questions.
Sì. Stadio.
That's me. Only one. It's not a yearly thing. It's just that. Well, there's the people that have gotten full rides, but you can't guarantee it anything, but it'll open it up to scholarships. You couldn't get other. So you just get a larger group of scholarships you can apply to. Yeah. That's all the time, yeah. As a PTA member, you'll be open to other scholarships.